of Training and Technical Sales. We like to make this as interactive as possible, so please use the question area on your toolbar and we'll get to as many questions as we can throughout the next 45 minutes or so. For nearly 50 years, BTX has been the premier AV distributor of emerging technologies, signal processing products, and integration essentials, offering our customers access to solutions to grow their business. Our focus lies firmly in creating value by delivering outstanding products and services. BTX supplies many thousands of the finest interface, integration, and systems products, as well as engineer our own unique and patented solutions. We have deep technical expertise on all of our solutions that we provide, and our applications engineers, inside and outside sales teams, are readily available to help you specify, purchase, and then support your product requirements. Our full product line card offers thousands of products to make implementation of your projects run smoothly. Among the many key integration building blocks that we provide are custom cable assemblies, custom plates and panels, video extenders, signal distribution, and cable management. So when you work with BTX, you work with a team of people whose mission it is to bring you new ideas to excite your customers, enhance the elegance of your design, drive revenues and profits to your bottom line. Now we're going to move on to the main attraction as I hand this over to Ken. As a reminder, please feel free to ask as many questions as you can throughout the presentation.
Excellent. Thank you, Kim. Are you,
I can see your,
seeing my presentation here?
I can see your presentation.
Wonderful. Good. I don't need to change anything. All right. Good morning, everybody. Thank you for being here today, and welcome to this presentation from BTX in ATLONA. Today, I want to accomplish a couple of things. As Kim mentioned, we've launched several new products this year since early on and through Infocom. And one of the consistent themes across our products has been the ability to be able to transmit 4K. And I know as I've traveled around and talked to different people around the industry, there's been a lot of questions about 4K. And so what I hope to do today is maybe answer a couple of those questions, at least at a high level. So we'll start out and go through a little bit of 4K, and we'll take a look at some of these new products that ATLONA has launched and how 4K fits into those and how they fit into different applications out there. And please go ahead and ask questions all the way through. If you miss an opportunity, I will leave some time at the end too so we can circle back and answer those. And I believe Kim has also made a copy of this presentation available somewhere there on your GoToWebinar control panel. You should see a section for handouts, and I've provided a PDF version of this handout so you can, I believe, Kim, that you can click on it there and just download it right from the control panel. Is that correct?
That is correct, Ken.
Excellent. Thank you. All right, so as we get into 4K, there tend to be 5 areas where we get a lot of questions at. So I like to break the presentation down into the top 5 things that are important to know about 4K. So we'll spend just a moment and talk about 4K resolution, bandwidth requirements for transmitting 4K, cable limitations, what's out there for 4K content, and everybody's favorite topic in the world of 4K, HDCP 2.2, and we'll briefly talk about how that affects your installations as well. First topic is 4K resolution. What is 4K resolution? 4K resolution is an image that is 4,096 pixels horizontally on the display and 2,160 pixels vertically on the display. When you multiply these two numbers together, you get a little more than 8,800,000 or 8.8 million individual pixels on the screen. So a lot of detail in a 4K image. The question then becomes, what is the aspect ratio of a 4K image? And if we take that horizontal resolution and divide it by vertical resolution, we get aspect ratio. And we'll see in a 4K, standard 4K image, the aspect ratio is 1.9 to 1 or 17 by 9. And so that begs the question, what's the aspect ratio of all the flat panel displays that we use in the industry today and even most of the projection out there? And the answer to that is those screens are all 16 by 9. So what happens when we put this 17 by 9 aspect ratio 4K image onto a 16 by 9 screen? we get gray bars in the top and bottom, which isn't what we want to see in our nice 4K image. So in order to combat these gray bars that we see on the screen, the industry has created another or an alternate resolution for 4K, which is called UHD or Ultra HD. Ultra HD is a 16:9 aspect ratio image, and it's 3,840 pixels wide by 2,160 pixels tall. So notice it keeps the exact same vertical resolution, but we shorten the horizontal resolution. And when you multiply these two numbers together, you get an image that's 8.3 million pixels on the screen versus the 8.8 that we saw in 4K. So in reality, there are two types of 4K images. There's the native full 4K, which we might see out of something like a engineering application or maybe something coming off of a computer. And then there's the UHD, which is more of a consumer type of resolution that we see on flat panel displays today. In order to get this resolution, 7% of the horizontal resolution was removed to create the UHD image. So in comparison, if we look at this chart here, you'll see we'll start from the small and work up. You have the small green box here, which is HD, 1080p, 1920 by 1080. That's the resolution we're familiar with today that we call high def. It's a little over 2 million pixels on the screen. Now, before we had HD, we had 2K, which is that slightly larger red rectangle there. 2K was 2048 by 1080, or a little over 2.2 million pixels on the screen. The problem with the 2K image was it also didn't fit that nice 16:9 aspect ratio, so the horizontal image on that was shortened, and that's how we got HD or 1080p that we use today. So fast forward to today, we have 4K. That's that larger orange box you see on the very outside there, 8.8 million pixels, and then the slightly smaller blue box just inside that, that's the UHD that we just talked about, nearly 8.3 million pixels. A couple other resolutions that you might see, even if you don't see these, it kind of leads to the next question I guess, which is, okay, so we have 4K resolution. Are we going to skip past 4K and go on to 8K? What's going to happen with the resolutions here in the future? Well, I throw these two gray boxes up to show you what's kind of been the trend. If you look at the inside gray box there, this was a resolution that Apple used for a while. It's 2560 by 1440. Was a often called display port. It's larger than a 2K image, 3.6 million pixels on the screen. And then fast forward to today, again you see Apple pioneering another high resolution display. They have a 5K monitor actually on the Apple website that you can purchase. It's 5120 by 2880 resolution. That's almost 15 million pixels on the screen. That's 5K. So will we go past 4K and jump to something larger like 5K? It depends on the application. You're not going to see mass applications going to 4K. In fact, you'll see as we talk about bandwidth requirements, it's going to take a lot just to get infrastructure up to handle 4K. So going to 5K is going to be purely application driven. And in this case, it's a desktop monitor, which means you're sitting up close to a desktop monitor. You're probably working on graphics or things without motion. So it makes sense to have a nice high-res 4K monitor, a 5K monitor rather, in a desktop application. But typically on a display screen, we wouldn't necessarily see that. Second topic then is bandwidth. We know a bit about 4K resolution now. The question is how much bandwidth is needed for that 4K resolution? And the better question here is what's the bit rate? And bit rate is something you might often see on a listing link for cables, a cable spec. So bit rate is going to consider more than just the number of pixels that we're going to send to the display. Bit rate is also going to consider how much color is in the picture and the refresh rate of the image. These factors together will help us determine how much bandwidth is actually needed. Now, one of the things that we know about 4K bandwidth or bit rate is that depending on the number of pixels combined with how much color and the refresh rate of the image, we could have a 4K bit rate that's anywhere from 3.5 to 20 gigabits per second. Now, these aren't numbers you need to memorize, but just to give you an idea, there's some variable factors in that 4K image, and they could go quite high. if we take a look at the technology that's available for us today, the cabling infrastructure, and we look at HDMI 1.4, we know that can handle 10.2 gigabits of data. But we keep in mind the actual 4K bit rate can be between 3.5 and 20. 10.2 falls somewhere just in the middle of that. So that suggests HDMI 1.4 can handle some level of 4K, but not necessarily all 4K. Then look down one more bullet point. I've also got HD-based-T written in there, which is a format you'll see that Alona uses a lot. That also handles 10.2 gigabits of data, so again, falls somewhere in the middle. And then some new technologies hitting the market now, HDMI 2.0 will handle up to 18 gigabits, so we'll do quite a bit more. But again, that's a specified application. That suggests you've got HDMI 2.0 ports on your source, you've got 2.0 infrastructure, and you've got HDMI 2.0 input on your display as well. And this is going to be relatively short runs to get you high resolution 4K over HDMI 2.0. So the most common use really still today is going to be HD-based-T because it gives us the longest distance use of 4K. Just know we're limited to 10.2 gigabits, which means there's a certain type of 4K that we can send, and that 4K that you're going to see, which has kind of become an industry norm today, is 4K at 60 hertz using the 420 or 8-bit color scheme. And that fits within the 10.2 infrastructure, and that's the type of 4K that we see today. And that's not unique to Alona. That's pretty much unique to everybody using the technology that's out there today. So some cable limitations. Oftentimes I get asked, what type of cable can we use with HD-based-T and with Alona products? The answer is twofold, really. One is the HD-based-T protocol is built on a spec which suggests that we use Cat6A shielded. So in other words, when HD-based-T puts out specs that say maximum distances could be 328 feet when using the Class 8 HD-based-T chipset, they're assuming they're using Cat6A shielded cable and crimp down the end, and the cable's not crimped too hard anywhere, and you follow proper installation techniques. But oftentimes I'll get asked, well, we're working on a job where Category 5E cable is already pulled. Can we use that cable with the Alona products? The answer is yes. You can use it with our products, and you can use it with resolutions up to 4K. However, keep in mind that as you use a lower grade of cable, while we'll still be able to transmit a signal, your maximum distance is going to drop as well. And so I've got a chart here on the next page, and you don't have to memorize these numbers. You can pull them off the ATLONA'S training website where you can see these numbers, and it'll kind of give you an idea of the maximum distances you can run based on different types of cable using HD-based-T and Alona products. And you see in the first box here on the left, we're talking about the HD-based-T Class A chipset, which is the more robust version of HD-based-T. It carries an Ethernet signal and has maximum distances up to 328 feet. And based on the chart here, you can see when our signal is 1080p and we're using Cat5e or the Cat6a or Cat7 cable, you get the full 328 feet of distance. However, as your bandwidth increases to 4K, notice on the Cat5e, our maximum distance will actually drop down to 230 feet, where on the Cat6 and Cat7, we stay at the 328 max distance. And then on more budget-conscious jobs where you might be using the Class B chipset and or maybe your distance is just less and you don't need Ethernet, with the 1080p signal, Cat5e will give you a maximum distance of 197 feet. The Cat6A, Cat7 will give you the full 230 feet for the Class B chipset. And then when your signal increases to 4K, you start to see some significant distance drops. Now, Cat5e will max out at 150 feet, Cat6A, Cat7 at 130 feet. So again, no need to memorize these here. Just note that cabling will affect your signal transmission distances. However, you can use different types of cabling here. One point I would make on the box on the right, where we say near the bottom, Cat5e, Cat6, 35 meters or 115 feet. If you're doing a retro type of installation where an older grade of category cable exists and you think you're going to be sending a 4K signal, I would recommend in this type of application, do not specify the HD-based-T Class B product for the job. Instead, specify the Class A chipset. It is a little bit more pricey than the Class B, but look at the transmission distances. You actually get double the distance when using the Class A chipset than you would over the Class B chipset. So if you're sending 4K, it would definitely help you to use that and probably worth the extra investment. 4K content. All right, so we know now somewhat of a historically slow adoption with getting 4K content. Why is that? Number one, bandwidth, large file sizes. If you get the opportunity sometime this week, go out to YouTube and pull up a 4K resolution file. You'll see there'll be little, maybe 5-minute 4K clips on there. And if you try to actually download one of those, you'll see it can be several gig of information in a 5-minute clip, which is the size of a 1080p high-def image. So you see there's a lot of difficulty in sending a file that's that large. So as compression techniques get better and new algorithms come out, we'll see those file sizes shrink and we'll be able to distribute those some more. Also up to today on the more engineering or technical side of 4K, you tend to have bulky, expensive PCs. Maybe they require multiple outputs or graphics cards, so they're not always the most user-friendly interface for the 4K. Up until recently, a limited range of 4K displays have been available. Now we have a lot of new factors that are accelerating some of the adoption of 4K. Using compression algorithms like H.265. Some of you may have heard of a file type called H.264. It's a compression algorithm that we use today in Blu-ray. So it's been proven. It's good. H.265 is the evolution of that. We're seeing that being deployed more and more into new hardware now. More affordable 4K recording devices. In other words, handheld cameras, live action cameras, movie studios recording with 4K, more source devices supporting 4K as well, the introduction of HDMI 2.0 and 4K 60 Hertz, and now a much wider range of 4K displays, including projectors available on the market today. Even on the consumer side, you're seeing advances in services like Netflix offering 4K content as well. So there's a lot more coming out there, but it has been some slow adoption, but you're going to start to see a lot of that change, and I think by the holiday purchasing season, you'll even start to see 4K Blu-ray players out on the market as well. Key here really being, if you're working with an application where your client requires 4K or believes they'll need 4K in the future, build the infrastructure today to support that 4K content that they're going to have tomorrow. And to do that, you need to make sure you follow some of these best practices using the right cabling. If you have older category cable, make sure you understand the limitations of that and pair that with the correct ATLONA infrastructure products, which will handle the 4K distribution, and we'll see a glimpse of those here in just a moment. And the last topic is HDCP 2.2. Just something to watch out for. I'm sure you're all familiar with HDCP. That's content encryption. It's been around for a little while. The Hollywood industry brought that out with the evolution of Blu-ray and high-def discs because they wanted to protect their copyrighted material. What's copyrighted material? It's generally it's movies coming out of Hollywood. It's things you purchase. It's anytime you put in a disc and it's got that FCC disclaimer at the front of it, that's copyright protected material. So the security measure, HDCP 2.2, to protect that copyrighted equipment is a hardware device. It's a physical chip that's installed inside of products. So in order to show 4K copyright material, you need to have hardware that is HDCP 2.2 compliant. In other words, the hardware has to have this HDCP 2.2 security chip inside of it. If you're not showing copyrighted material, no issue. You can show 4K content all day. But if you have an application where you're going to show copyrighted material or a Blu-ray type of content, 4K content, make sure all your equipment is HDCP 2.2 ready to go, compliant, and you will find that the ATLONA equipment is all HDCP 2.2 compliant. So you won't have an issue there, but if there's anything else in your system, make sure it meets the 2.2 compliancy as well. All right, so let's jump in now and take a look at some of the new products that ATLONA has launched this year, including all of those features in 4K that we just talked about here. So on this page right here, you see our new extenders for this year. We launched 4 new types of extenders. You see them across the top there. And let me just talk about that naming convention first, starting with the first extender. The first extender there you see is the AT EX70 2PS. Anytime you see UHD in front of an Alona product, that means it's Ultra HD or it's 4K. That's a 4K product. EX means it's an extender. 70 means you have the 70-meter chipset inside of it, which is the Class B HD-based chipset. 70 meters is also equivalent to 230 feet. Now, this first product on the left of the chart here is the 2PS, which means this product requires 2 power supplies, one on each end, the transmitter and the receiver. This is a kit. It's designed to be an inexpensive alternative for sending a quality HD-based signal from one point to the other. Beside that is the UHD EX70. This is the same device as the first one, except that it uses our PoE-based HD-based power scheme, which means the transmitter will send power to the receiver. The receiver at the other end does not need to be powered. Beside that is the UHD EX70C. Notice we've added the letter C to the end of this part name. C stands for control, and that means that this transmitter pair will have the ability to send bidirectional IR and RS-232 control. And the last product on the end, the UHD EX100CE, a couple things change here. Notice we put 100 in the part name now. That means this is the 100-meter or 328-foot HD-based Class A chipset. And we've added the letter E to the end of the part name. E stands for Ethernet. So if you need more distance and or you need to send an Ethernet signal to the display, the 100CE is the correct product for that application. Now, a couple other things to note about these extenders. There were some intelligence designed into some of these here. You'll notice that each one of these extenders is 1/4 rack width in design, which means we can set 4 of these down side by side in a rack shelf for a nice, easy fit, a nice, convenient fit. You'll notice that the firmware port is on the front side of these, which means if you've installed this in the rack, your installer can get right to the firmware port for easy update on these without having to pull a rack out. And then all of the cabling will output to the back side of the extender and out the back of the rack, which means all the cabling is tucked away and hidden by the rack for a nice, neat, easy installation. All of our products feature 12-volt IR control, and all of our extenders are HTTP2 compliant and use PoE or power over Ethernet. Notice at the top of the slide here, actually the first bullet point, I've written out here 4K at 60 hertz or 420 color. I mentioned that earlier. That's the 4K scheme that you used for all of our products. 4K 60 hertz and 420 color is the same thing as 8-bit color. One other thing I'll call your attention to on this slide here, as you're looking at the image of the extenders, you'll see there's a LAN port on these. The LAN port is black, and there's an HD-based T port. The HD-based T port's blue. You'll find this theme through all of our products. This is so as an installer, it's real easy to connect. LAN ports are always black, black to black. HD-based T are blue, so connect blue to blue and make sure that everything's set up correctly on the install. These new extenders are replacing some of the older models. So if you had been specifying in the SI40, the HDTX or RX, or the HDRSnet series of extenders, you'll need to stop specifying those and specify the new ones that we just mentioned there. We've also released a new series of HDMI switchers. These are called the UHD SW5 series. Again, UHD means these are 4K compatible. SW means these are switchers. And 5 series mean these all have 5 HDMI inputs. And there'll be a mix of outputs depending on which model you choose. The top center is the SW51, which means you have 5 HDMI inputs, 1 HDMI output. You also have audio breakout for left-right analog or the digital coax PDF connection as well. In the lower left is the SW52, 5 HDMI inputs, 2 HDMI outputs, and on the audio breakout here, you have a balanced audio output for left-right audio, and you have the digital coax output there as well. I notice on the back of each of these you've got firmware updates also, and then in the lower right corner is the SW52ED. We've added the designation ED to the end of this model number. ED stands for extended distance. So we have the same 5 HDMI in, 1 HDMI out, and a mirrored HD-based T out beside that HDMI. That's what the extended distance means. So I have a 100 meter or 328 feet HD-based T output on this as well, so I can connect 2 displays, one locally and then one long distance over the HD-based T. Notice also all 3 of these models have LAN ports on the back of them. This is another theme you'll see across all of the new ATLONA products, the addition of the LAN port, which means all these devices are IP controllable. In most cases, you're going to find a real nice web GUI interface, so you can access each one of these devices on the network through a web browser for convenient control and operation. Switchers that are being replaced. So if you've been specifying the HD4 series, the V41 or the V42, move away from UHD SW5 series. Those are the new ones now. These are the old ones being replaced. Then into the CLSO category. CLSO stands for Classroom Small Office. Hopefully some of you are familiar with this. We launched the CLSO 612, which is the product there in the center, 1 year ago, last summer. And then earlier this year, the top product, the CLSO 601, and then most recently the CLSO 824 there on the bottom. So these are ideal products for the classroom or small office. These are switchers. Some of them have a scaler built into them. And let's start with the one at the top first, the 601. Again, these all say UHD in the part name, which means they're 4K compatible products. 601 means that this product has 6 inputs with 1 output and a second mirrored HD-based T output with it. So looking at the back of the 601, you see you have 4 HDMI inputs, 2 VGA inputs. So those are 6 inputs. And then on the output side, you have an HDMI with a mirrored HD-based T next to it. So we can have 1 local monitor, 1 long-distance monitor. This device also features a built-in 4K scaler. I'll handle 4K or UHD at 30 hertz. Has a microphone inputs on it as well. You also have audio embedding built into the VGA ports here. Audio de-embedding built into the device, so we can take audio out to a separate room amplifier for the audio system. This device uses PoE or Power over Ethernet, so you pair that with one of the new receivers that we looked at earlier. Auto switching is built into this as well, and again, you also see the LAN port on the back of this, so you've got TCP/IP control on it, as well as control via RS-232 IR and the buttons on the front panel of the device itself. Just below that's the 612. That's the one we brought out earlier this year. A couple of extra features on the 612. On the input side, you have 2 HDMI. You also have the addition of 2 HD-based T direct-in inputs, which means you can pair this with one of our HDVS transmitters to bring an HD-based T signal directly into this switcher. You have 2 analog inputs there as well, and on the output side, you also have an HDMI with the mirrored HD-based T. The same features for microphone, audio embedding, and audio de-embedding built into the 612 also. This device features PoCC, which is a 24-volt power scheme, which means this is the only device in the CLSO series. We would use one of the older extenders with it because we could take advantage of the PoCC power scheme in that regard. And the bottom device, this is the new one we brought out at InfoComm this year, the one there's been a lot of buzz about. In fact, after bringing out the 612 and the 601, a lot of feedback we got was, can we get a CLSO that does matrix outputs on it? So we brought up the 824. That's exactly what it is. It's 8 inputs with 2 matrixed outputs, and each matrixed output has a mirrored additional output beside it. So you can actually connect 4 displays, but you can have 2 different sources showing at any time. So looking at the back of this here, you've got 3 HD-based T direct inputs. So we can have 3 HDVS 150 transmitters connected to the CLSO. You've got HDMI inputs on there as well, 4 of those, plus an analog input on there. And then look on the output side there. This is the lower right of the CLSO 824. This is the bottom image. You have 2 HD-based T 100-meter outputs. Those are matrixed. And beside each one of those, you have a mirrored HDMI output. So 4 displays can be connected. 2 sources can be shown at any time. So here's your matrix classroom or office switcher. This is a powerful device, great, a lot of cool features packed into this. Taking a quick look at a line diagram for the CLSO 824, you get an idea here. You'll see all of our inputs there across the top being fed into the CLSO. Then down at the bottom, notice we've got 2 displays down there. These can be matrixed, and then over on the right, there's a third monitor, a confidence monitor, which could be tied to one of those matrixed outputs so that a speaker could see exactly what he's got on the monitor coming up. Switchers that are being replaced by the CLSO series are the Line Pro series of products. So if you're specifying the Line Pro series anywhere, replace these with one of the new CLSO products. So Line Pro 2, Line Pro 4, or Line Pro 5 Gen 2 products are gone away. Replace those with the CLSO model. You heard me mention earlier the HDVS 150. Hopefully you guys are familiar with our HDVS product. It's a great line of transmitter receivers that allow you to get an input in, send it up to 230 feet to a display on the other end. So HDVS is a great product for us. But with the 824, we're using PoE, power over Ethernet, and our original HDVS series uses the POCD, or the 24-volt power scheme. So for the interim, we've introduced a product called the HDVS 150, which also uses PoE, power over Ethernet, so that it can be used directly in conjunction with the 824. So just take note of that. If you're buying the 824 and you want to use the HDVS input, you want to use the HDVS 150 just so you can be on the power over Ethernet power scheme and these 2 devices are compatible. Otherwise, there's no changes to that HDVS product. Now, going forward, we're also announcing a brand new update to the HDVS series, and this will be called the HDVS 200. We introduced this at the Infocom. It will be shipping this fall. The HDVS 200 has a transmitter and a receiver. The transmitter would sit where the presenter is going to be, maybe mounted under a conference table or at a podium. The transmitter will have 2 HDMI inputs and 1 VGA input with an analog audio input beside that, so we can embed audio onto the category cable with the VGA video signal. At the transmitter, there's a couple of updates here for the presenter in that volume control has been added at the transmitter so the presenter can control volume, and a display button has been added to allow the presenter to change inputs on the display as well in case there's an additional source located in the room that's being fed directly to that display. You also have the receiver. That's the bottom image there. Notice on the receiver you've got breakouts directly for audio, so you can go right to an in-house audio system. You have breakout for RS-232 for control of that display. You've got a LAN port on the back of this, which means from an installation standpoint, this guy's going to be available on the web, on the network. You can pull it up through a web browser. Very easy to set up and control. Additionally, the HDVS 200 will also support 4K resolutions, and it will support transmission distances of up to 100 meters or 328 feet because it will be using the HD Base T Class A chipset. So some great new features being added to the HDVS. Keep that in mind. This is a great product with some wonderful new upgrades to it. So if you're looking at applications where HDVS is the right fit, take a look at the HDVS 200, see if this is the right fit for your application. Quick drawing of that, you can see here on the left is my transmitter with a couple of input devices. Then on the right I have my my receiver control processor connected to that. I'm outputting to a projector, and then audio de-embedding is going out to another ATLONA piece, the PA100G2, which is a small in-room amplifier that can be used to power a pair of speakers. sold with the HDVS200. Great kit. The Matrix series of products for ATLONA has also been upgraded this year. Everything has moved to the Pro 3 series platform. The two models you see on the screen right now are the 6x6 and the 8x8. These are available and shipping now. Notice they all have UHD in front of the name, which means these are 4K switchers. Also on the back of these devices, look at the one in the lower left corner here, the 8x8. You'll notice on the output side, the first four outputs, 1, 2, 3, 4, have the letter ED next to them, which stands for extended distance. This means these ports use the 100-meter chipset. So if we're outputting to a display at a longer distance, we can output on these. Outputs 5, 6, 7, and 9 use the standard display using the HD-Base-T Class B chipset. So we're going to output 230 feet or 70 meters on those. Also on the output, you'll notice there are two HDMI outputs there as well. Those HDMI outputs can be mirrored to match any one of the HD-Base-T outputs, or they can be put into matrix mode, giving you two extra outputs, which means the 8x8 becomes an 8x10. Notice the 6x6 has this feature as well, so the 6x6 would become a 6x8 output. A cool new feature, you won't find that anywhere else but on ATLONA products. Also notice you've got audio de-embedding on each of the first 4 zones on the 6x6 and the first 6 zones on the 8x8, so you can take audio directly out to an amp. Those audio outputs also feature 5-band EQ plus volume control and mute. So the DSP is built right into the switcher. No need for an extra device to do that. These products are also HDCP 2.2 compliant, so will work with any 4K copyrighted material as well. Now on this screen here, you'll see the UHD Pro 3 44M, which is the 4x4 matrix switcher, and the 1616M, which is the 16 input, 16 output matrix switcher. These will be available by end of the summer here. These products carry the same features that we saw on the 6x6 and the 8x8. Notice on the 4x4, there's only one extended distance output and one HDMI output, which would make this device, if you put it in matrix mode, a 4x5. And then notice on the 16x16, there are 4 HDMI outputs on the right side of the back of that unit. So you have an additional 4 HDMIs that can be mirrored to any of these matrix out, any of the HD-Base-T outputs. Or those 4 HDMIs can be put into matrix mode, making your matrix switcher a 16 input, 20 output device. So some cool new features on the HD-Base-T Pro 3 series matrix switchers. The matrix switches that are being replaced. So again, if you're currently speccing any of the Pro 2 series, 8x8 or 16x16, or the Pro 3 series, 4x4 or 6x6, change those out and put in the new ones that we just looked at in the Pro 3 series. These are no longer being sold. Everything's now the new Pro 3 series matrix switch. Excuse me. ATLONA has also released a new HDMI to HDMI series of matrix switchers. So these represent HDMI in, HDMI out, and you'll find these both in the 4x4 and the 8x8 configuration. These devices also support 4K and are HDCP 2.2 compliant. HDMI distribution amplifiers, these are not new in the line, but since we're talking about 4K, also worth mentioning the HDDA series of distribution amplifiers, that's HDMI in, HDMI out, also support 4K pass-through. We have these in the 1x2, 1x4, and 1x8 configuration. We also released a new audio converter this year called the UHD M2C BAL. BAL stands for balanced. So this is a multi-channel to 2-channel audio de-embedding device. It also features EDID and HDCP management, and it will handle 4K at 30 Hertz with the color resolutions at 422. A quick show of that display here using the M2C BAL. Notice the BAL at the end of that part number means that you have balanced audio output coming out of this device, so it's ideal for commercial applications when you need to pull audio out of a system and run it into a set of speakers for the room or for the application. And the last product I want to leave you with is called the AMS, or ATLONA Management System. This is a software product which will be out later this year. This product will be very handy for your installers and your engineers. Your installers, particularly on the job site when you've installed several ATLONA products. Remember earlier I mentioned this theme of having an Ethernet port on the back of all of our new products, so you have easy IP control. You can stick these on the IP network, standard IP architecture, and you can hit each one through its IP device, the mini web server, or if you download the ATLONA management software, have this on your local laptop, which would also reside on the network. You can see all of your devices, all of your ATLONA devices at once through this software tool. This will allow you to configure each of the devices, push down firmware updates, manage control on each of these devices. You'll even be able to load blueprints or maps of the application and locate products on the map exactly where they are within the physical application. Even remotely, from an engineering standpoint, this becomes a real powerful tool for remote management of a job. So if you've got several ATLONA products installed and 3 months down the road you need to do some maintenance or a firmware update, an engineer can actually log in remotely, connect to the ATLONA product, and push updates down remotely to the software without having to make an extra trip out to the job site. So the ATLONA management software, available later this year, IP-driven, really designed to help make you more productive and really driven as kind of a way to reduce costs and increase efficiency during installations with ATLONA products. So watch for that product. It will be available through the website. It's a free product that you'll be able to download to support your ATLONA products with. And last thing I'll leave you with now, moving beyond ATLONA product, is ATLONA Academy. Don't forget about this site, ATLONAacademy.com. This is our education and training site where you can find all of videos on our products. You can find our e-learning portal and our content library, which features all of our white papers and training documents as well. If you haven't already done so, register for ATLONA Academy. That's our online training program. We offer certification courses at 100 level, 200 level, and 300 level. I recommend everybody gets in and goes to our 100 level foundational technology course. Beyond that, our 200 level courses feature ATLONA products and give you a much deeper understanding of what's available and the applications you can use those products for. And then beyond that, you get into our 300 level design level courses. These are all completely free, and they carry CTS credits for Infocom. So I highly recommend you jump out there and today register if you haven't already done so. We'll leave it open for some Q&A now. Kim, it looks like we might have a question in there.
Yeah.
What's the replacement for the HDTX and RX? What about the price point for the new item? So let me just jump back a couple slides here real quick so we can answer that, which might be quicker if I get out of that and go right to it. Okay, so the question is, what's the replacement for the HDTX and RX? So for the HDTX and RXs, you're going to use the EX70, UHD EX70 transmitter and receiver. Pricing will be similar to what you saw on the TX and RX in the past. You also have the ability to jump up to the EX100, which would be a replacement for the RSNet series if your application requires you to run longer distance. But this slide is in the presentation, so you can feel free to download that. That's in PDF version right through the control panel of this GoToWebinar session. You'll be able to grab this slide right out of there as well. Kim, do you see any other questions on your side there? That's the only one I'm able to see here.
I don't see any other. Oh, wait. So is your HD base T a true HD base T, or is it a light version?
That's a great question. All right. So we actually feature both. So with HD base T, you have what's called the Class A chipset, which is the full, or in stated in the way of your question, true HD base T. You'll see that anywhere we say 100 in our products, that means 100 meter. That means it's using the Class A or the full or true HD base T chipset. The light version is the Class B chipset. So anywhere we say 70 meter, or you have the 70 designated in the part number, that's what you refer to as a light version of the Class B chipset. So we actually offer both. And the reason we offer both is because for flexibility. Sometimes you may require the full 100 meters. Other times you may only require the 70 meter and don't need Ethernet, or the budget doesn't allow for the full. You just need the light or the 70 meter version. So with ATLONA, you have access to both.
Great. Okay.
Good questions, you guys.
I'm going to take back control, if that's okay.
Yep.
So
yep.
I want to make sure that people make me the presenter. See if I can talk and do something at the same time here. If you, of course, we carry all ATLONA products. Everything is in stock, so whatever you need, please feel free to either go to our website or give us a call. Also, if you have any technical questions, you know, we're definitely the stop you should make. Also, if you want to download the presentation so you have a copy for yourself, like Ken mentioned at the beginning, go to the Handouts tab on your control panel, and you can have it. There's a lot of great information. So.
And one other thing I would mention too, Kim, on the ATLONAacademy.com site under the video tab, or even through our YouTube channel, you will find a number of videos on all of these products we talked about today. You'll also find a full presentation of 4K that I did earlier this year. What we talked about today was really just kind of a brief snippet of 4K. So if you're really looking for a deeper understanding of anything with 4K or cabling or what goes into that 4K 60 hertz 420 signal, you can watch that video. It's out there on the YouTube channel as well as our ATLONA Academy video page.
Yeah, you guys do an excellent, excellent job of educating the market space. So it's definitely a great resource. Everybody should definitely bookmark it and use it often. All right, well, it looks like we've come to the end of this program. Ken, thank you so much again for working with BTX and putting on this presentation. And thank you, everybody out there, for joining us today.
You bet. Thanks, Kim. It's our pleasure.
Okay, great. Bye-bye, everybody.